Hello, everyone. Tonight we're going to be talking about, let's say you have two populations, okay, and we want to find the confidence interval for either the sum or difference, usually this is the difference, of their averages. Okay, now we're running out of daylight a little bit on this. So next week I want to have a test. So probably on Wednesday we'll have a test. So we'll have a little bit of time on Tuesday for review because we don't meet on Monday. Test on Wednesday, and then Friday, and then the following Monday, I guess, probably do the review for the final ish, something along those lines. Okay. So I had hoped to do one other one besides this one, but life will go on. This is the one that we're going to finish with for confidence intervals. So if you have population one, and again, I think the easiest one to do is husband and wife when they first age at first marriage. Okay, you with me? So first marriage. So you're gonna get a lot of I was 27, I was 23. Okay, I was 26, I was 26, I was 25, I was 21, I was 25, I was 25. No, I was 26. Oh, and so eventually you'll have a few. Okay, and of course you got the old, I was 82, I was 63. Like, oh, age gap. And then of course you got one of these ones, 37, 93, and no, whatever. Okay, I'm joking, but you get the point. Okay, now the husbands will have some average. Do you know what it is? No, I don't. And the gals will also have some mu, and of course, no, don't know it. By the way, I probably also don't know this. No, don't know it, and I probably don't know this either because if I did, I'd probably be God, and if I knew that, then I'd know the other thing, and I'd be God. And so, what's the point of doing statistics for crying out loud, right? The average difference is blah 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 blah. Oh, okay, cool, thanks. That wasn't very hard. And so when you do that, you're like, okay, this makes sense. Okay, so what do? I take a sample. Obviously, sample size N1, size N2. They don't have to be the same. And well, in this case, they have to be. In this case, they kind of have to be the same. But anyway, yeah, actually, you do have to be kind of the same on this one because, yeah, you're taking a difference between the husbands and the wives. Okay, but whatever, you get the point. So there they are. Okay, great. Yeah, so you kind of probably want to do the same, but that isn't always true. So sometimes you can just do an average of different things like that. So anyway, here's the game. So when we have this, okay, we're gonna find x bar, obviously, from the sample, x bar from the sample, and of course sx from the sample, sx from the sample. Okay, Groom, now what? Well, here's the thing. And so we mentioned this previously briefly. I briefly mentioned it one time, one day, is this. If you have a population over here, and we're going to specifically talk about normal right now, but if x is distributed normally with a mean of mu 1 and a standard deviation of 1, like this, right? And x2 is distributed normal, mu 2, sigma 2. Okay, so they're similar, but they're different, obviously, right? Then x1 minus x2 is also distributed normally, and the average difference is just mu 1 minus mu 2. That's it. Okay, it's just the difference in their averages, right? So if this was 60 and this was 50, the difference would be 10. Are you with me on that? See, it makes sense, right? And by the way, so if I did plus or minus, it'd be plus or minus, right? So it's either like 110 if you plus them or 10 if you minus them, right? Okay. But here's where it gets interesting. The standard deviation is the square root of the sum of their variances. Okay, so variance, if you recall, from a z-score, right? So z is equal to x bar minus mu over sigma over the square root of n. And by the way, I use sigma, but we're going to be using sx, of course, right? This guy right there is my standard deviation, yes? So the variance for this would be sigma squared over n, right? Over n. So that's what I have down here. Now, why is that the case? Again, picture this husband-wife scenario, as it were. And let's go sample some stuff. Now I'm going to create some data. You're welcome. And I'm just going to what's called randomly generate some data here. So random number generation. And so I'm going to one column of data. I'm going to put 1,000 points in it just for fun. So 1,000 dudes. Okay. And normal. Average age, they got married, 27. Sure. Standard deviation of 2. Sure. Why not? Output range. Let's put that in. Done. And this is the dudes, the husband. Nice. And then the wife. Oops. It's not how you spell wife, loser. Wife. That a boy. Now, let's try that. Now let's simulate some data for the ladies, as it were. Okay. Yeah, so I want the gals to be a little younger because that's typically true. A little more variation. Now, by the way, if this comes back kind of goofy, like, oh, there's a 17-year-old. Well, okay, it's Georgia, I guess. I don't know, whatever. Boom, done. Okay. And, yeah, we'll just pretend we didn't see that. There you go. Okay, whatever. Anyway, there it is. So we said if you were to do equals average for A2 colon A1001, that's the average for the men. We said it was supposed to be 27. The population was supposed to be. Notice that my sample of 1,000, 26.955. Well, that's about as close to 27 as the guy's going to get. Am I right? Am I right? I feel like I'm right. Now, theoretically, if I drag this over, it took the latest. Yes, there it is. Perfect. Now, let's do the standard deviation. So, STDEV dot P of A2 colon A1001. All right. And we'll drag that over. Oh, look, it's about 2. Weird, because that's what it's supposed to be. Oh, weird. Oh, look, it's about 3. Weird. Shut up. Now, watch this. Suppose I say equals. Let's take the difference, okay, of this fella minus this lady. And if you post that all the way down, watch. And then watch this, bro. Watch me do the following. What? Whoa, that's weird, bro, because I feel. What happened? Remember, this was supposed to be 27. Yes? This was supposed to be 23. What is the difference between 27? Oh, dude. That's righteous, man. Now, interestingly enough, we said the standard deviation was, what did we say it was? Well, we said it was equals the squirt of this fella, square, divide by 1,000, right? Because there's 1,000 dudes, plus this fella, square, divide by 1,000 ladies. Oh, what did I just do, for God's sakes? You moron. Let's try that again. So that squared divided by 1,000. Oh, did I do it right? Is that 1,000? Mr. Green, don't you have your glasses on? I do have my glasses. Oh, hang on. Yeah, okay, hang on. Let me back to train up here, folks. Let me back to train up. Boop, 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 boop. Now watch this. Right, so we said that we knew, or we had a pretty good idea, that the standard deviation for the 1 is 2. So 2 squared plus 3 squared square rooticated is 3.6. 3.6. Do you see that? And so, again, what we said is back over here, we said, listen, it's just you, oh, damn it. Hold on. Erase this part here. We haven't got there yet. Okay. What we said is this sigma squared plus sigma squared square rooticated. There we go. Done. Okay, that's what I should have said. Now, we're going to change that up and go with this part here in just a second. So panic not. I jumped the gun a little bit, and I'm sorry. Please forgive me. Okay, anyway, back over here. As you can see, that's what happened. Now you're like, Green, what if I added them? Well, what do you mean? What if I did equals this fella plus the lady? And you're like, Grim, it's supposed to be 23 plus 27. It should be 50. Check it out. It's about 50. But look what happened. Our standard deviation is still bigger. So whether you add or subtract, your standard deviation will always get bigger. And that's because, again, you could have a really, let's say if you found an old dude here. Look at that geezer. Holy crap. Oh, married a young chick. Interesting. Age gap. All right. So that's interesting. Whoa, look at, oh dear. Oh my. Oof. Oof. Anyway, big difference, right? But at some point, there's going to be a gal that's big older than the dude. And when that happens, what ends up happening is, especially if it's minus, it's a little more obvious to see the difference. Well, literally the difference because you're minusing. Literally. I feel like that's something Dom would say. There it is. So anyway, there it is. So you can see some of these are negative where the lady is bigger than the dude. And so when you minus, you get a negative. You're like, whoa, that's cray cray. Well, think about that. You got some negative numbers plus some positive numbers, and negative numbers and positive numbers. They're going to be even more spread out than the original were. So you're always adding the variances. Now, that's nice, Groom. What are you saying? Well, what I'm saying is this, bro. I can make a z-score, you see, for the difference of these two means. You with me? So it's going to be x bar 1 minus x bar 2 minus mu 1 minus mu 2. Now, you should really pay attention to this. We will be using this a lot later. Today, we're just learning how to do this thing. You're going to be like, oh, this is easy, of course. But later on, we're actually going to use it to do something else. So as the way I like to do things is I like to teach you something, and then we can then use the same tool to do multiple things so you're not learning something new later on. You're like, Grim, this is exactly like a regular z-score. I mean, a regular z-interval. No, I know. So we're going to solve for this. Are you with me? Wait, but isn't that going to be just, wait for it, isn't it all going to come down to this thing here, x1 minus x2, you with me? Plus or minus z yes, DA, that's how it's going to go down. And that's it. So, Grim, are you saying that if the ladies are so we take a sample average and we said, hey, we said X bar for the dudes was, this is for the dudes. We said that the average was 37. This is on there. I don't even care. It doesn't matter to me. 2. And for the ladies, all right, X bar is 39. Yeah, baby. And SX is 5. What does that mean? I don't know. I want a 95% confidence interval. Let's go, dog. Boom. So when we do, oh, by the way, N equals 50 and N equals 70. Why did I do more ladies? Because I want to meet the ladies. I don't know, man. It doesn't matter. So 37 minus 39. Does it matter which way I minus them? Yes and no. Yes and no. So oftentimes I want to say, listen, I want to know what's the difference husbands and wives. And I specify husbands minus wives. Does that make sense? Other times I don't care at all. I just want to know, is there a difference? Later on, in particular, in chapter 9, we're going to spend some time talking about this. And we're going to prove, for instance, whether there is or is not a significant difference, for instance, maybe in test scores for men and women in math. And yeah, we might do that later on. And so it's going to make a difference. So in that case, there is no difference. Somebody could say, Groom, I think that boys tend to out-hit girls in golf. Huh, okay. So you're saying that boys minus girls would be a positive number because boys' distance would be bigger. Yeah. Okay, then you specified which way you had to minus. Does that make sense? But in this case right now, it doesn't really make any difference. And I'll show you why momentarily. Plus or minus 1.96 squirt. It's going to be 2 squared over 50. That's 2 squared, which is 4. I'm just going to write 4 over 50. Plus 25 over 70, yo. Let's bust out the calculator. To the day, I'm in my college class, and I bust open a calculator like that. And it ends up being on a different screen, and I'm looking all over for the world for that thing, and I cannot find it, and I'm getting so pissed off. And I finally realize it's on a different screen. I feel like a complete buffoon. Sorry, personal problems. Groom, that's TMI. I don't want to hear about TMI, miss. I just shared my what you guys call that? Your lore, 0.64. By the way, Mr. Norton had not heard of the concept of lore. And so then this one girl told him her lore, and it freaked him out. And I was like, oh, yeah, no, I heard all about it today. 1.25 plus minus. So that's going to be -2 plus 1.25. So -2 plus 1.25. -0.75. And if I minus them, that's -3.25. So what I'm saying is that the difference, the way I minus them, is somewhere between 3.25, -3.25, -0.75. If I had minused them the other way around, I would have gotten, of course, 0.75. Oops, I'm sorry. Hang on. I'm sorry. Don't get all butthurt. Holy buckets. 0.75. If I minused them the other way around, I would have gotten this. But what it really is saying is this. It's saying, oops, damn it, and I didn't subtract it back. What it's saying to me is that when I subtract, mu2 is somewhere between 3/4 and 3.25 bigger than mu1. Does that make sense? So listen, again, this is the way Groom looks at it here. I'm taller than you. You're shorter than me. Does that make sense? It doesn't really make any difference. What we're saying is it's the difference is between them. It's just a matter of which way you're looking at it. In either case, mu2 is bigger than mu1. How do I know that? Because when I take mu2 minus mu1, I'm getting a positive difference. You with me? The other way around, I'm getting a negative difference. I take the small one minus the big one. But it doesn't change anything. Please note that there is a number. Our good friend, this guy, 0. He's a hot little number. I like that guy. Look at 0. Do you notice that 0 is not in here? Did you see that? 0 is not in there. We are pretty sure, we're 95% sure that the true difference is somewhere between 0.75 and 3.25, or on negatives. Either one, doesn't matter. But you know what it's not? It's not 0. What is that? What are you saying? What we're saying is that there is a significant difference between these two guys. It's significant. In other words, if it equaled 0, if this was -0.75 to positive 3.25, 0 tends to lie in here with that difference. You with me? What would that say? So, Groom, what you're saying is that there's literally no difference. That's what I'm trying to tell you. Yes, Vienna, pay attention. That's exactly what I'm trying to tell you. So if 0's in there, and again, we're going to hit this again in Chapter 9. We're going to talk more about that. We're going to say, hey, listen, if 0's in there, we're saying that the true mean is somewhere between here and here. And 0's also in there. So what does that tell me? I'm pretty certain that there is no significant difference between the two things. If 0 is not in there, then there's a significant difference. And whatever that means, right? So in math class, oh, well, there's no difference in the test scores between boys and girls. Okay, whatever. Yeah. Blah, blah, blah. You know, oh, well, let's do that one. Let's do that one. Oh, Groom. Let's try that one. Golf drive distance. All right. Oh, cool, great. So you got the guys on the big golf tour. The guys are hitting, I don't know, 300. Yeah, on average, I guess. Oh, Groom, that was so 10 years ago. Well, okay, whatever. And this sample, Groom, are you going to go a bigger sample? I am. Could you do this with a t distribution? Yes, but we're not going to. We're going to stick with bigger sample sizes for right now, okay? The lead is, the average is 260. All right. Mr. Groom, is that... Listen, sister, if I'm 6'6" or 6'3", with the big old long arms, and I can get that more mass moving, yes, I probably can hit it farther than someone who's a 5'9" or whatever. Yeah, probably. Yeah, yeah. But I feel like, take it up with God. I didn't make the rules. I just did. That's just how it is, bruh. I also can't fit into cool places. I don't, I can't dance. You understand, okay? Okay. So here's the game. I want a 90% confidence interval this time, and I want mu1 minus mu2. You know what I'm saying? So I'm gonna. Oops, stop it. So I'm gonna go 3 honey minus 260. That's our difference. In other words, 40 plus or minus. You with me? Plus or minus. Z, 1.645. 1.645. Squirt, 25 square over 30 plus 20 square over 40. Need a calculator for that. Doop 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 boop 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 be doo. Well, 25 square is 625 divided by 30 plus 400 divided by 40. Bam. 5.55. Jeez. So 1.645. Oops. Get it. Stop it. Times 1.645 is 9.13. Boom. So 49.13 on them. It would be the maximum difference that we're confident in saying between men's drives and women's drive. And on the lower end, it's going to be, what is that, 30.87 yards. Okay? Yay! Notice 0 does not live in here. What does that say? That suggests that there is a significant difference between the two. I know. You want another one. I know. I'm working on it, bro. I don't know. Juniors, sophomores. Number of tardies. Number of tardies, sure. Average number of tardies, what is it? I don't know. So I take X bar equals 63. SX equals 9. Is that per kid, groom? I doubt it. N equals 40. And X bar equals 67. All right. SX equals 11. N equals 40. Right on. So it doesn't matter which way I minus them. Me personally, I usually do the bigger one minus the smaller one because I'm not a big fan of negatives. Like, it harshes my mellow, man. 95% confidence interval. I'm sorry, it's freaking 9:30 at night. And I just remembered here not too long ago that I had not made the video for tonight. And so, dang it. Anyway, here we go. Oops, you dirty hippie. 81 over 40 plus 121 over 40. That's hot. Here we go. So 1.96 times the squirt of 81 divided by 40 plus 121 divided by 40. Da, 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 da. My margin of error is 4.4. Oh, this is hot, friends. This is hot. So that's 4 plus or minus 4.4. Well, that's 8.4 dot 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 mu 1. That's actually mu 2 minus mu 1. Not that it matters a great deal. Negative 0.4. Dude, 0 lies between here, yes? Whoa. So in this case, this suggests to us, and again, we're not doing this today. Today, all we're doing is this. You with me? But what we're moving toward in Chapter 9, we're going to use this for, is to do the same thing. Hey, 0's in there. What does that mean? Means that juniors and seniors are just as equally bad hellions. They're just as equally bad. Because 0's in there really is truly no significant difference in the number of tardies or referrals, or whatever the hell, I forgot what I said. Anyway, there's no significant difference. Ergo, if you were, I don't know, Mr. Shirley, he cracked down on them equally hard. You know what I'm saying? If it is the freshmen, of course, those losers, we're going to have to really crack down on those guys, right? Because, they're hellions and they're all over the map. Okay? I don't know. Something to that effect. Okay? Hope that helps. You got this. It's really not this hard. For gosh sakes, just go back to this page, you dirty pig. Go back to about wherever this is. Oh, no. Go back to right here, baby. Write that pig down. That's all you got to do. Dump it in. Let's go. Let's go! All right, good night.